Okay, so good day everyone. For today's lesson, we will be discussing about operations on radicals, laws of radicals. To start with, let's have the first theorem. So the first theorem is we have the nth root of A times the nth root of B. We can write that one as the nth root of A times B. So we can multiply the radicand since we have the same index, which is the n. So for example, if we have square root of 12, the square root of 12 can be written as square root of 4 times 3. And then we can separate that one. So we have square root of 4 times the square root of 3. But the square root of 4 is square root of 2. So that's why we have 2 square root of 3 for the square root of 12. So that's how the theorem 1 works. For the theorem number 2, so let's have square root of 27x to the cube and then square root of 6x squared. We can simplify the 27 to 3 to the cube, x cube, and then for the second part, which is the 6, is 3 times 2x squared. Then we can multiply. So we have 3 to the cube x cube times 3 times 2 x to the squared. And then 3 to the cube times 3 is 3 to the 4 by the laws of exponent. And then times 2 x to the fifth. But we can simplify this one into 3 to the 4 x to the 4 then times 2 x. And then we can have this one by the laws of the exponent. We have 3 squared x squared quantity squared times 2 x. And then by the law of the theorem, then we can have the 3 squared x squared square root of 2x as the final answer for example number 2. So that's for theorem number 1. Let's move for the theorem number 2. So for theorem number 2, we have nth root of A over nth root of B is equal to the nth root of A over B. Meaning, if we have the same index, we can directly divide the radicand, the numerator over the denominator. But of course, B should not be equal to 0. So for example, if we have fourth root of 48 over fourth root of 3, we can write this one as the fourth root of 48 over 3. And then 48 over 3 is 16. And then the fourth root of 16 is fourth root of 2 to the 4. And then the fourth root of 2 to the 4 is equal to 2. So meaning the fourth root of 48 over the fourth root of 3 is equal to 2. Let's have another example. So for x is not equal to 0, the cube root of negative 1 to 8 x to the fifth is over cube root of 4 to 4x. We can write that one as the cube root of negative 1 to 8 128x to the fifth over 4x. To simplify, we get only cube root of negative 32x to the 4 because negative 1 to 8 divided by 4 is negative 32 and x to the fifth divided x is x to the 4. Then we can simplify the negative 32 to negative 2 to the cube times 2 squared, and then x to the 4 we can simplify that one as x to the cube times x. So for those who have the exponent of cube, then we can extract that one from the radicand. So we have negative 2x cube root of 4x. So 4 here is 2 to the squared. So we have cube root of 4x. So that's for the example number 2. Now let's have the last part, which is the theorem number 3. This is what we call reducing the index. So mn of A, and then we can write this one as the mn of nth root of 8. Example, we can write the sixth root of 64 as 3 cube root of square root of 64, but square root of 64 is just equal to 8. So we have the cube root of 8, but cube root of 8 is equal to 2. So that's why sixth root of 64 is just equal to 2. And then also for number 2, we have fourth root of cube root of 5. We can write that one as the 12 root of 5. And we cannot simplify the 12 root of 5. So that's the final answer. So that's all for the first part of the operations on radicals and the loss of radicals. Thank you. See you in the next video.